I've been looking forward to this. Rather than talk about TRAPPIST-1E, I'm going to instead talk about the TRAPPIST-1 system in general, because it's a very fascinating system. So the TRAPPIST-1 system consists of an ultra-cool red dwarf star, orbited by 7 Earth-sized planets, and some of these planets are in the habitable zone around the star. TRAPPIST-1 is what's called an ultra-cool red dwarf star. Ultra-cool because it's very small and it's very dim and it's very cold for a star, especially a red dwarf. It has an average surface temperature of about 2000 Kelvin, less than half the temperature of our Sun. For a star, TRAPPIST-1 is actually very small. It's barely bigger than the planet Jupiter. And the entire TRAPPIST-1 system that we know of, because there may be undiscovered planets still, could neatly fit between the Sun and the orbit of Mercury. Naturally, that means that all of these planets are so close to each other that if you stood on the surface of one of them and looked up in the sky, you'd be able to clearly see all the others, almost as if they were moons. This will bring some problems which we can address later on. For now, let's look at the planets, shall we? Welcome to TRAPPIST-1b. It looks like a colossal, overly cheesy pizza. Disavow. It is slightly larger than Earth, but it more or less has the same mass. Unfortunately, this planet is way too close to its star in order to be in its habitable zone. Early estimates assumed that this would be a Venus-type planet with a thick atmosphere, but this is unlikely because the surface temperature is likely to be a lot hotter than Venus, maybe as high as 1200 degrees Celsius. The planet completes an orbit around its star every 36 hours. Estimates put it at 1.07 million miles away from its star. For some context, Mercury is 51 million miles away from the Sun. With a possible temperature up to 1000 degrees, it's very likely that this planet is just molten lava. So yeah, let's get away from this cheese fest. This is TRAPPIST-1c, finally away from the cheese, but it still looks more promising than Birmingham. It's the third largest planet in the system, but it is the most massive. It's about 1.4 million miles away from the Sun, and estimates put it to be a Venus-like planet once again, with a very thick atmosphere. Unfortunately, the estimated surface temperature is around 61 degrees Celsius. Scientists would call that toasty. We are just outside the habitable zone. Any water on the surface will presumably be turning to vapour very quickly. And like with nearby 1b, because these two planets are so close to the Sun, it is very likely that these two planets are going to be tidally locked, with one side permanently facing the Sun and the other side in total darkness. A lot like how the Moon has one face permanently towards the Earth and the other side permanently away. And despite the Sun still being very dim, this planet will still receive 2.1 times the amount of sunlight as Earth does. So it really is more like a twin to Venus. Next is TRAPPIST-1d, or as I like to codename it, Dewsbury. 1d is actually the smallest of these planets, much less massive than the Earth and about 3/4 its size. It is just over 2 million miles away from its star, and little Dewsbury here is just about inside the inner habitable zone. And even though it's very close to its star, 1d receives about the same light as the Earth does from the Sun, along with a similar temperature to the Earth. But once again, as you can see in this artist's illustration, the planet is likely to be tidally locked, with one side completely baked in sunlight and the other side complete darkness. The one thing to bear in mind of all these tidally locked planets, they may have really thick atmospheres with high atmospheric winds, which transfer all of the heat from the daylight side over to the night side. So you may end up getting an even circulation of all the heat. Otherwise, your best bet for life is somewhere in the middle, known as the Terminator Zone. And it completes one orbit in just 4 days. And despite the inhospitable atmosphere, it does remain one of the most Earth-like planets we've found. Next is planet 1E. We're getting bigger again. 1E is almost the same size as the Earth. In fact, it is similar to Earth in radius, density, and mass, and even temperature. And with a density similar to Earth's, it's safe to assume that this is a solid rock planet. Unlike the density of the other planets, which are far more likely to have steamy atmospheres like Venus, some form of liquid ocean, or a thick ice shell, this one is exactly dead inside the habitable zone. It's probably the best candidate for finding liquid water, though unfortunately it is still likely to be tidally locked. A year on this planet lasts about 6 Earth days. As this was the original question, I'm going to give my quick thoughts on it. I am fairly optimistic that there could be areas where there's liquid water, but at the same time, this is a planet that is likely to be tidally locked to the star. And there's another concern I have as well. Much like the power of the moon's gravity, which moves oceans on the Earth, and how the gravity of Jupiter is affecting its moons Io, Europa, and Ganymede, I'm a little bit concerned about the tidal forces that could be coming from the nearby planets. So whilst 1E may be more suitable for life than Birmingham or Luton, at least based on the data, there are still other factors to bear in mind. Next is OneF. Personally, this is my favourite artist illustration. I hope a planet like this exists somewhere. The frozen eye of Sauron. Once again, this planet is nearly identical to Earth in mass and size, but unfortunately it sits on the outer edge of the habitable zone. While scientists have been able to possibly detect water, they don't know what state it's in. It could be in a liquid state or it could be in a gas state. It supposedly has a thick atmosphere. Because its mass is about 2/3 that of Earth, it's unlikely to be a fully rocky planet, and also unlikely to be Earth-like. 1 year on this planet lasts about 9 Earth days. What? Did God look at the colour of the sea in Jaywick or Clacton and just think, you know what, I'm going to put that colour into a planet? TRAPPIST-1G. Sitting at 4.3 million miles away from the Sun, this planet is outside the habitable zone. It is larger than Earth, but it is less dense. So it could host some water. It could have a global ocean or a super thick atmosphere surrounding a sheet of ice. A year on here is a little more than 12 days. The existence of water really depends on the atmosphere. And finally we come to OneH, about 77% as large as Earth and with 1/3 its mass. This planet is more comparable to Mars. We are now 5.7 million miles away from the Sun. Still nowhere near Mercury's orbit, but well out of the habitable zone. It's very likely that if there's any water on this planet, it's going to be entirely ice. Although it is likely to be water rich because of its similar low density with the other planets. But the temperature of the planet is likely to be similar to that of the South Pole on Earth. Remember when we talked about tidal forces from the other planets? It's very likely they could have an effect similar to the effect Jupiter has on Europa, where if there is water on this planet, it could exist deep beneath the ice, where internal temperatures are still nice and warm, while the actual surface is frozen. A year on TRAPPIST-1H lasts about 18 Earth days. So there we have it, the TRAPPIST-1 system. This has by far been the longest video I've ever done. If you've made it to the end, congratulations. Well done to you. I should also mention the TRAPPIST-1 system is a target for the James Webb Space Telescope. Whilst in terms of space exploration we were born at the worst time, there's still an opportunity for us to learn even more.